Hi, everyone. We have a terrific hour ahead of us, so please take your seat and we can get started right on time. I also hope you'll pause for a moment and recognize our land acknowledgement on the screen. I'm Jenny Wyatt, the president of ARCS Foundation Seattle chapter. Oh, my table. I'm delighted to welcome you to our 45th anniversary luncheon. We are so grateful you are here with us today to help us recognize an important milestone for our Seattle chapter. I'm thinking back 45 years ago. Some of you weren't born yet. Back then, I was a graduate student myself, expecting my first baby girl, with absolutely no inkling of the innovations yet to come. DNA sequencing, magnetic resonance imaging, GPS, fiber optics. What phenomenal progress has been made in the last 45 years. And that's why ARCS Foundation exists, to support scientific advancement, past, present, and into our future. For those of you new to ARCS Foundation, we are an engine for innovation and scientific research. Our approach is to provide unrestricted financial awards to outstanding scholars in the STEM disciplines at WSU and UW. Our Seattle chapter is so proud of all that we have accomplished in the last 45 years. Since 1978, we have given over $23 million in awards to outstanding scholars at the UW and WSU. And we now support over 50 academic departments at UW and WSU by helping them recruit top graduate students. You will hear a lot today about the ARCS mission, advancing science in America. But for a moment, let's look beyond our mission statement to those who embody our mission. You will hear from current ARCS scholars and ARCS alum. These scientists are launching us into our future. They are our moonshot. Yes, there is a theme here, launching and moonshot. For our 45th anniversary celebration, we are so honored to receive a special message from an ARCS alum and NASA astronaut, Dr. Jessica Meir.
Hello, I'm NASA astronaut Jessica Meir, coming to you today from the Johnson Space Center in Houston. First of all, I'd like to commend the ARCS Foundation Seattle chapter for 45 years of igniting and enabling scientific innovation. Thank you for your support. I was once an ARCS scholar pursuing a PhD in marine biology from the Scripps Institution of Oceanography. I know I am in good company with so many ARCS scholars and alumni here today. My ARCS fellowship came at a time when every penny counted, whether it be research dollars or living expenses. My fellowship contributed to my ability to earn my PhD, a crucial stepping stone that launched my previous career in academia as a comparative physiologist and brought me one step closer toward achieving my dreams of becoming an astronaut. Since those early graduate school days, much has changed. In 2013, I received the opportunity to serve as an astronaut, my dream job since I was 5 years old, the one offer that could draw me away from fieldwork. In 2019, I fulfilled my aspiration to fly to space, and even participated in the first all-female spacewalks. It was truly an honor to conduct research across all scientific disciplines on board the International Space Station, benefiting humans back on planet Earth and enabling future space exploration. ARCS scholars, As you continue the challenging work of pursuing your education and research, remember that without risk, there is no true reward. Remember to push the envelope, to think outside of the box, and to follow your heart. Seek out solid mentorship, particularly from those that appreciate you as a person, not only as a scientist, and pay that forward by mentoring someone with less experience than you. Congratulations to all of you, and best of luck with your future pursuits. Science and exploration are only made possible with robust support and consistent opportunities. Thank you, ARCS community, for recognizing the potential of these young scientists to enable scientific discovery and progress.
I have to tell you, I've watched this video so many times, and each time I watch it, I feel a little choked up at seeing Dr. Amir's joy in following her passion. To continue, I'd like to thank our university partners, the President of the University of Washington, Dr. Anamari Kase, and the President of Washington State University, Dr. Kirk Schultz. Our universities are absolutely essential to our mission. To scholars and alums, our superstars, thank you for being with us here today. Would you please rise so we may recognize you? It's an impressive group. I'm also pleased to thank our luncheon sponsors: Washington Research Foundation, Zevenbergen Capital Investments, Fred Hutchinson Cancer Center, Laird Norton Wealth Management, Wyman Youth Trust, AHT Insurance, USI Insurance Services, UW Medicine, Tint Cellars, and Fouché and Associates. We are grateful for your partnership in advancing science. And now we're going to take about a 5-6 minute break, and then I'll be back to introduce another outstanding ARCS alum, our keynote speaker today, Dr. Jevin West. Hello again. I know that was a little too quick, and I'm sorry to interrupt your conversations. I am so excited to introduce our keynote speaker today, Dr. Jevin West. Dr. West was a Seattle chapter ARCS scholar from 2005 to 2008. About 15 years ago, he sat in a similar hotel ballroom and was one of our scholar presenters. Today, he is an associate professor in the Information School at the University of Washington. His list of accomplishments is awesome. And just to make sure I don't forget anything, I'm going to refer to some notes. Dr. West is the co-founder and the inaugural director of the Center for an Informed Public at the UW, which aims to resist strategic information, promote an informed society, and strengthen democratic discourse. He is also the co-founder of the Data Lab at the UW, a data science fellow at the eScience Institute, and an affiliate faculty for the Center for Statistics and Social Sciences. His research and teaching focus on the impact of data and technology on science, with a focus on slowing the spread of misinformation. He has published more than 100 articles and given keynotes around the world. His work has been widely featured in the media, including the Wall Street Journal, the New York Times, CNN, The Economist, the Washington Post, the BBC, and research journals Nature and Science. He also co-authored a book, Calling Bullshit: The Art of Skepticism in a Data-Driven World, which helps those of us without an advanced degree in data science understand and question numbers, data, and statistics. Please welcome Dr. Jevin West.
Thanks so much. All right, well, thank you so much, Jenny, and thank you to Jen and all the organizers for ARCS, and thank you to all of you for just showing up, and all of the students. I can't wait to hear more about all the things that you're doing. So I'm going to talk a little bit about some of this work that I've been doing over the last several years, but I do want to say that my training is in theoretical biology. I did a postdoc in a physics lab. I was studying things like the schooling behavior of fish. Now I'm studying the schooling behavior of ideas on social media. So this shows the ways in which you can move from one idea to another, and organizations like ARCS give you that kind of freedom, and that's the freedom that I was given. And I really do genuinely think that part of why I'm here is due to ARCS. Oops, I got the wrong clicker here, sorry. And I was almost going to lose it here. There's two clickers. All right, so when I received my ARCS fellowship, so I wanted to start this with a slide thanking ARCS, and I was funded by Nancy, I even say it wrong, Sevenbergen, and so I know that Nancy is watching right now, and her table's out here somewhere. You supported me in 2005, where are you? So I just want to see. Oh, there, okay, there we are. All right, good. Okay, thanks so much. Now, in 2005, there were all sorts of things that happened at that year that were pretty world-changing. One of them was the advent of YouTube. Some of you may remember that. Some of the ARC scholars were probably so young, they were maybe in diapers still. But YouTube has been pretty phenomenal in its ability to allow someone like me and my kids to go to a live view of the International Space Station, and maybe see our former astronaut on there too, maybe, and look at this station moving around this spherical object, and you can do this in real time. You can do this now. Pretty amazing, right? That's the kinds of things it can do. But the kinds of things that I study and worry about are the things that I took a screenshot of when I was watching the live stream of the International Space Station, and there was questions about 10 strange things you didn't know about the Earth, and is Earth actually flat? That's where we've come from since 2005, this amazing technology that now asks whether the Earth is flat. By the way, Neil deGrasse Tyson right there, he's also an ARCS fellow, and I at least could have clicked on his video there. So this is the world we live in. Now, I'm going to take a little bit more serious example here. So this is an image that came out and hit the world on May 22nd of this year. Some of you may have recognized this image. It was a supposed bombing at the Pentagon. It's a fake image. It was generated by AI, and it was debunked and taken down pretty quickly after it went up. But in that short amount of time, the markets moved about $500 billion. There was a lot of concern locally in that area. Internationally, it got news. And it was generated with one simple set of technology that any of you could create as well. So we now live in a world where this kind of influence is possible with the technology that we have. And the thing that concerns me actually more than even just this individual image and the market moving it did is that people are going to start to become jaded. And they'll just say, oh, it's just a fake image. But what happens when it's a real crisis? These are the kind of situations that I worry about each and every day. Now, most of the work that I do and my colleagues do in our center is play around and study the sort of darker corners of the internet. And it can give you a pretty depressing view of the world. And so it's so nice to come and talk to real people in person to say there are real people with good intentions, which is nice. But I've been spending more of my time truly offline looking at the effects of misinformation, and specifically misinformation as it relates to medical myths. I've been talking to lots of national organizations and local organizations that are representing the doctors that we see every day. And one of the groups that I got a chance to talk to was the American Emergency Physicians Group. And the stories that they were telling me about the kind of misinformation that they were seeing each and every day really got me worried more than I already am. I'm a very worried person all the time about this particular topic. But there were story after story of the kinds of things that they were dealing with each and every day that wasn't just the heart attack they needed to deal with, but the information that someone had coming in. And I'll give you one example that's really stuck in my head. One story was a patient during COVID. This was locally here at a hospital here near Seattle. And this patient came in with his arm literally falling off at the elbow. He had a construction accident and blood was dripping. Sorry, you're eating food right now. But there's bandages wrapped around. And the protocol at the time was to get a COVID test. So they asked this person, you need to take a COVID test and then we can get you in and take care of you. He refused the COVID test because he had been reading online that ethylene oxide was going to cause cancer for him. And he refused, so the doctor said, we have to take it. He turned around, walked out of the emergency room with blood dripping. It's the last those doctors saw that patient. That's how serious it is. In fact, this, among many rumors just pop up. They're popping up every day, and this is one of the things we track all the time, that the Department of Health for the state of Washington had to come out with a flyer on ethylene oxide, in addition to every other rumor that we're playing whack-a-mole with, and had to say this doesn't cause cancer. Ethylene oxide, by the way, is what sterilizes the nose swabs. But think about any kind of rumor that can pop up. These kinds of things are taking our doctors' time, our Department of Health's time. This is the kind of thing that we're contending with all the time. And this is coming from the highest offices in health in the United States and internationally as well. The Surgeon General actually reached out to me and our center prior to the pandemic, talking about this issue of information health. They're recognizing that you can't deal with this issue of population health if you don't also address the information health. And that's exactly what we do in this center. That's really a public-facing center that my colleagues and I formed back in 2019. We started with just a few of us faculty and a few students. We've now grown to almost 50 people when you include all our undergraduates, PhD students, postdocs, research scientists, staff that are tracking these kinds of things in health, in politics, you name it, all across the information space. But 50 certainly isn't enough because this is one of these gigantic problems that touches every element of society. Now, core of what we do is research, but we're a research group of biologists, physicists, philosophers, psychologists. We have computer scientists. I mean, pretty much across the spectrum, because this, again, is a topic that hits every one of these different disciplines that many of you represent. And we also do more than just research. We do a lot of public engagement and education. One of our kind of crown jewel programs that we do once a year in collaboration with Washington State University across the state of Washington is something we call Misinfo Day. It's one of these one-day of the year that some of these high school students, that might be the only day they ever get to talk about media literacy and misinformation and what they can do to become better information consumers. We bring them to campus during COVID. We reach thousands of people, and it's actually growing outside of Washington, and it's a program we see going nationally. But I'll mention one program that spun off this, which is called Misinfo Night. And this is driven by high school teachers and high school librarians. What they do is they teach these students for an entire semester, then they teach their grandparents, their parents, and their neighbors in an evening event that I've been to many times. It's phenomenal, and it's things like this that I think gives me hope as well. Now, as I mentioned, this is a collaboration with Washington State and UW, and it's something that we do across the state of Washington, and these are the kind of collaborations like this event that get me excited. In fact, we see our two leaders here, Kirk and Anna Mari, back in 2019. This was this is probably minutes before the pandemic really hit, and then off we went into misinformation land around the pandemic. But we also do a lot of work on the policy side as well. So I got to help write one of my first bills that actually just got passed this year around deepfakes and election material that the governor signed and had a press release about. So this shows that you can do research but also have policy effects. In fact, it's going across the country. We're one of those states. And also, if even states like Wyoming, I can make fun of Wyoming because I grew up on the border of Wyoming and Idaho. If Wyoming has a deepfake bill, we can do this across the country. We can do all this. Now, misinformation is something that really requires, a long-term play and education, and we even make games like an escape room. We create tons of material that we make freely available that are based on research that we do. And I'll give you kind of an example, the kinds of things that we've had influence on with industry partners, and that is like so Google, for example, here. Something that didn't exist even just a short time ago were these little vertical dots here. I don't know if I have right at the top of every search query on Google now, you'll see 3 vertical dots. Those are dots that we've been encouraging search engines to do so that you can be a fact checker and get to the same material that others can. So if you click on those 3 dots, you'll get information. By the way, this is the wrong screenshot. I talked to the Menopause Society about misinformation too. It's not the ARCS Scholar. That's not what would pop up if you searched ARCS Scholar right there. But if you really clicked on it right now, you would get information about the websites, how long they've been around. This is a great tool that I wish we would have had 10 years ago, 15 years ago when I was an ARCS Scholar. Now, the reason why we care about this is because in our field, we do try to do predictive work. People say, are you just always playing whack-a-mole with all the rumors? In fact, right after this, I'm running and talking to a reporter from The Atlantic, and then we just had some things on NBC and CBS just a few days ago with some of the work that we were doing. Yes, because rumors tend to be like tropes in movies. When you see one, you're likely going to see another in the same event. So when you see sharks swimming in the street today in a hurricane, you're going to see it in the next hurricane event. And in that, you get to use some of these tools, which again, these are brand new with images now on Google, which is also, I think, influenced by some of this new things. You can actually see that this is a shark image that showed up 10 years ago, has been debunked multiple times by fact-check agencies, and shows up time and time again. So these are the kinds of things that we do in our center. So what I want to do for the last half of the talk is give a few thoughts to the ARCS scholars. I was sitting in your place back in 2005, and there's some things that I've learned thinking about misinformation, both in society and in science. So I thought I'd leave a few pointers that would be helpful. First of all, science is a social endeavor. And I think we saw that in line when we were, during the pandemic, for better or worse. By the way, this is a screenshot of what my Zoom picture looked like when I was teaching during the pandemic. It was very depressing and sad. That's why I'm so happy to be back in person. And science is very much an in-person, banging ideas together. This is what we want to do, is get back to it. Now, in science, we pride ourselves in our quantification techniques, and I teach classes in data science. Actually, one of the first things I did on the education side when I got to UW was to help develop some of the data science programs in our school and throughout the university. But numbers carry this kind of authority, and sometimes that can be intimidating. We want to ask questions the same way that we ask questions of at any other time in our life, but we don't ask questions enough. And we also underestimate the value of descriptive science. All you scholars out there, don't feel bad if you are doing descriptive work. I think that's some of the best work that we do in science. And so, case in point about numbers, at least questioning them because they have that authority and replicability, watch out for Luncheon talks because 37% of them actually include made-up statistics. So watch out for those kind of things. That's what we got to be careful of. Now, one of the things that you may not think relates to you now, but I have found it occurring over and over and over again, no matter what kind of science you do, if you care at all about the translation of your science. And that's something from what economists call Goodhart's law. And this is this idea that giving bad answers is not the worst thing that we can do, or any sort of metric. The worst thing that we can do is encourage bad behavior. So this is a law that has kind of a complicated definition. Any observed statistical regularity will tend to collapse once pressure is blah, blah, blah. So the better is Marilyn Strathan's. When a measure becomes a target, it ceases to be a good measure. But even better than that, when a measure becomes a target, people do stupid things. So let me give you an example from the pandemic. Working in the, on lots of misinformation during COVID, we had lots of examples, and we can track those, so we have that luxury of seeing what goes viral. Here's an example. I'm making fun of Midwestern states. Don't worry, I am from those areas, so I will do the opposite in just a second here. But there was a rule that was being placed in Iowa at the time, and it said this, if you read it at the bottom, that those exposed to the virus for 15 consecutive minutes within 6 feet need to be quarantined after exposure. The idea was that if someone got the exposure, they didn't want them if you got the exposure longer than that, you had to then be quarantined. So what did they do? They decided to lift the kids up every 12 to 14 minutes and mix them up. I think that's the opposite of what you'd want to do, exactly what they want. So these are the kinds of things. So when you're doing science and it gets communicated, you as the scientist need to be aware of the ways it's going to be manipulated. Now, I could write it I'm writing an entire book, my colleague and I are writing just on selection bias. So I had to give you one example of selection bias because you're going to run into it all the time in your science, and you're going to run into correlation causation issues. So let me just say that everyone thinks they know the difference between correlation and causation, but they always make mistakes, including myself. And I love this article that showed the 50 most shared research studies of all time. This is of all time in health outcomes. A half of the news articles misattributed correlation for causation, and even worse than that are the actual trained researchers with PhDs that are professors at universities that were making that problem. So we all make those mistakes. But let's look at another thing that went viral during the pandemic. This one. This one went absolutely viral. It went all over in different languages. And this example is one where it was actually real science. There was an honest mistake that was being made. Here it was bald men were at higher risk. It was in a real journal, the Journal American Academy of Dermatology. This is not a predatory journal, by the way. I study predatory journals. These are not predatory. This is a real journal, honest mistake. The idea was that there was an association between baldness and COVID risk, and the hypothesis here was that there was some endocrine involvement in COVID pathogenesis. This got published. It went all over the world in lots of Facebook posts. What did they forget? What's age? I heard it. You guys are very good. And Forbes and many others had to retract this common cause. We make these mistakes all these time. So you've got to watch out for these common things that occur. Now, selection bias. Selection bias is one of those things that, again, you think you know, but you'll make mistake. So let me just start with an easy example that comes, actually my kids actually noted this because they kept hearing this on the radio when listening to the Huskies or whatever in football. They said, a puzzle from the insurance industry. Here you have Progressive saying if you switch, you get you save $500. If you look at Allstate, you save $498. That's a $2 difference, but $500. If you look at Farmers, $502. If you look at, Geico, you save $500. How is it possible that you all save $500 at each one? It's a selection bias issue. Because if you only look at the individuals that switched and their savings, and not the ones that didn't switch, you basically are just learning what it takes to actually have to file new paperwork and do all the work to switch. So that's a selection bias issue. Now let me give you a little bit more subtle. This is the most difficult thing I'll show this luncheon because it's not super trivial, but this mistake happens all the time. How many people have heard the Will Rogers effect? Not. Okay, we got 2 or 3. Lovely that you know, most people don't. So I wanted to give this. It's a subtle example. The Will Rogers effect is something that we see a lot in research, and it's an example of selection bias. So let me give you an example. So this is a quote. Will Rogers, by the way, he was a performer, comedian, all these things, and he noticed something really strange. When the Okies left Oklahoma, this is where I'm making fun of California, when they moved to California, they raised the average intelligence of both states. How is that possible? How do you raise the intelligence of both states? Well, let's look at it in terms of cancer screening. So the diagnosis in the 70s and 90s, the big difference is that we had detectors that could do a better job of detecting that we couldn't in the 70s. And so you might think early detection saved lives. And sometimes it does. I don't want to say that it doesn't, but I can show you how you can be fooled sometimes. So let me give you a little example. This is pretend data, but let's look at this. There's two different groups here. The metastatic one here we have in the localized one. The average lifespan of the blue colors is 6, and the average lifespan of 2. And what I'm going to claim here is that with early detection, it doesn't change the average lifespan at all, but it will change it in the different groups. So if you have early detection, you move this group into the orange group. That makes the average lifespan go up from 2 to 3. And when you have the average lifespan of this group going smaller, their average lifespan goes up. So just like Will Rogers' quote, they both go up. So the technology saves us, right? Well, not really. Both groups improve, but the aggregate doesn't. How? Sicker groups improve, but also get larger. Healthier groups improve, but also get smaller. These are the kind of subtle things that we think about when studying misinformation in science and how they travel even in our own beautiful institution of science. So I've written about this in the National Academy of Science. In fact, I'm on a committee call today I'm writing a consensus report about misinformation in science and about science, even though I'm the biggest fan of science, been a fan since I was a little kid, and that's where my training is. But even here, we need to be careful of this. So I'm going to end now by talking about generative AI, because who can't talk about that? No one can have a luncheon talk without mentioning generative AI and ChatGPT and everything. So I want to talk about its effect potentially on science. I'm writing a perspective on this right now with one of my colleagues, Emily Bender, and Carl Bergstrom on this, and we're hoping finishing this week. So it's on my mind. So generative AI has this ability, of course, to produce at scale science that might be good but also might not be good, especially in a world where we're already subsumed by papers. And there's all sorts of discussions right now about the effects that ChatGPT will have. Some are against this idea of authorship. I'm actually against it. I do think there's some real value to ChatGPT, but I am concerned. But this is my quick take of how I view these chatbots, at least as they affect something as important as the institution of science. I wrote this in the Seattle Times op-ed earlier this year. Since I study bullshit studies, there's a real principle. It's called Brandolini's bullshit asymmetry principle. It has got a real Wikipedia. You might not think you can believe me because I keep kidding you half of the time, but this is a real Wikipedia entry. The idea is simple. Easy to create bullshit, hard to clean it up. Very simple, right? So what did you think I wanted to do when these chatbots were coming out earlier this year? I wanted to ask them about the bullshit principle. So I went to Galacta. This is Metaversions. It was a large language model specifically trained on the scientific corpus, going to change science. It actually was taken 3 or 4 days after. But this is what I got to ask it before, my colleague and I got to ask it before it went down. So here's what the real law is. Here's what it said. It said, Brandolini's law, or Brandolini's rule, is a theory in economics, not true, by Gianni Brandolini, a professor at University of Padua, not true, which states that the smaller economic unit, the greater efficiency, not true, not true, not true, not true. It was basically bullshitting the bullshit principle, and that's how I view a lot of these different kinds of technologies. Now, they can make up citations. I asked it about my citations. Those aren't real papers by me. They have some similarity to the things I've written. So now my colleagues and I are calling them hallucitations. So watch out for those hallucitations. And even since I haven't had a chance to make fun of Bing, even though, of course, it's doing great things. I make fun of a lot of these technologies, but I make fun of everyone. So the problem right now is that you're seeing citations being thrown into responses that have a science relation or that are just questions that you ask these systems. And they look like science generated. But the important thing is they're post hoc citations. That's very different than how we create science in the news. But they do amazing things. So I had DALL-E. I said, give me a picture that represents generative AI. And these are the two pictures it gave me, which were pretty zombie-like. So you kind of have zombies here, and you have a matrix, sad thing. So, I mean, it can do amazing things, but that kind of makes me depressed about what generative AI does. And I can do things like take the Seattle troll and put it in oil paintings. I mean, this is amazing. The mixing and the synthesizing that it can do is amazing. That's a real image, by the way. Here's the troll. This is how I feel like I'm doing when I'm working online all the time. I got these trolls out there. They have this smirk on their face like we're always a step ahead of you, Jevin. Oh, and by the way, they create crazy, amazing styles. I mean, this is where AI, this is a fake image, of course, too. The Pope didn't do it. I wish it wasn't fake. This one is a really, really cool one. So with all the money that we are spending right now and there are billions being invested in generative AI. I hope it turns out to be pretty good. I thought it could do one thing for me. So what I had to do, I did this before my town hall talk last week because I wanted to see if it can do it. I thought, give me an image of the Seattle Mariners winning the World Series. What do you think it came up with? This is what it came up with. It basically short-circuited. It could not possibly have the Mariners. That means nothing. I've looked up every term. I've looked up every symbol. That means nothing. It's not going to happen to us guys in Seattle, so just give up. All right, now our search engine, I'm about to wrap up here and then turn to the real scholars in this room, but there's a lot that we can do both on the technology side and also on the resilience side. But even with the tools that we think are standard, beyond sort of the generative AI, they struggle. So this is an example, a very simple question that's not even that hard to answer. Is there a country in Africa that starts with a K? You can do this search. It still exists. I checked it again this morning. Here's the answer. While there are 54 recognized countries in Africa, none of them begin with the letter K. The closest is Kenya, which starts with K sound, but is actually spelled with a K sound. It's always interesting to learn new trivia facts like this. This is the technology that's supposed to help us debunk and solve this misinformation issue. That's why we have a big challenge. So the thing that really concerns me, this is the last thing I'm going to just sort of emphasize, is that there's this brittleness about this AI, which it does amazing things. I'm not going to deny that. But when it comes to science, we have to be very, very careful. I'll give you one example here. If I was to give you this as a challenge, and I said, OK, extend that sequence, what would be the sequence you'd extend with here? So you have A, B, C, D, A, B, C, D, E. What's the answer here? I, K, L. Good. M, right? Simple, right? Humans can do this easily. So there was a paper written in Nature Human Behavior just a little bit. We're writing a response to this right now that said, hey, look at these large language models. They have this emergent ability to solve analogy problems with zero-shot reasoning. That means they've never seen it before, which of course they have in their training data. And they have these results that show, look, this is how humans perform, this is how ChatGPT, so they must be thinking and performing like humans. Well, not exactly. We decided in our lab, and we've been doing lots of these kinds of experiments, what if we modified that sequence to now look like this? A, B, C, D, A, B, C, D, F. What would it be? Great. N, right? You solved it easily. When we did this modification for these very sophisticated chatbots, their performance dropped dramatically. And if you had a synthetic alphabet on something they hadn't seen, look at the red down there. You're basically seeing that. So we need to be careful with this technology. And because we can't reverse engineer them very easily, these are the kind of challenges we have looking forward into science, and all of you will be interacting with. So I say, and I said this in the town hall talk, we want to be amazed, but we need to be scared, we need to be critical and practical, especially as it relates to science. So looking forward, I just want to say this. I've spent years and years and hours, countless hours of my life dealing with this issue of misinformation, both in society and science. But one of the things that really does give me hope is the science that's actually being done, and it's by the scholars that are sitting next to you. Those are the future leaders of the big, really thorny, hard problems that we have ahead of us. And I'll end with this image that's pretty inspiring to me. This is an image from the asteroid redirection project that went quite successful. Scientists pushed this thing out, tried to see if they could redirect an asteroid and potentially save us later on. But I see another kind of asteroid coming at us right now, and at our democracies and at the institution of science. And it's the health of information, and it's the technology that's following. In order to avoid this asteroid that's coming, we need all, both scientists and the rest of society, industry, governments, journalists, everyone involved, so we can misdirect this asteroid from hurting our democracies and the institution of science. So with that, I want to thank you for listening and turn it over to the real scholars, and thank the ARCS scholars, ARCS situation, for what they've done. All right, so ARCS scholars, come on up. They're supposed to come up. I think I'm doing this right on the list. Come on up. They are going to now talk about some of their research, and I'm going to introduce the first ARCS scholar once they all get up here and get situated. All right, so we're going to hear from our 4 ARCS scholars this year, and the first one that gets to start the show off, which you're going to do great, Shanti. Shanti Garman is going to come up and talk about her research. All right, let's welcome Shanti.
Thank you, Jevin. As a biracial girl born to hippies a white artist mother, and a black musician father, my decision to become an electrical engineer was somewhat radical. We lived in Berkeley, California, and my parents worked hard but struggled to make ends meet throughout my childhood. As a teen, I came to believe two root causes for our family's woes were my parents' lack of a college degree and a stable career. This belief cemented my decision to pursue both. I loved math, science, and logic puzzles and had always excelled at these. And when I learned that electrical engineers applied these skills to design, create, and build computers and electronics, my enthusiasm soared. We didn't even own a computer in my house, but going to college to pursue a degree in electrical engineering was clearly the path for me. With the combination of scholarships, loans, and work study, I was fortunate enough to be able to attend Stanford's rigorous and inspiring electrical engineering program. The first time I considered graduate school is when I scored the top marks on an upper-level EE class midterm, and the professor wrote across the page, "Excellent!" exclamation point, and then grad school with 3 exclamation points. I can still see the page. I now recognize this professor was an early mentor for me. He encouraged and directed my thinking about possibilities for myself I had not really allowed myself to consider. I trusted in this new vision and finished the master's program in EE at Stanford. When it came to whether to continue on toward the PhD, I opted to go to industry. After 18 consecutive years in classrooms, industry was simply more compelling for me. Also, if I'm honest, I wanted to earn money. And I needed to earn money to help support my family. Some years later, after stints in engineering, product management, and nonprofit work, I felt pulled back to a rigorous academic setting centered around EE. I took the plunge, and now I'm in my 5th year of the PhD program at the University of Washington Department of Electrical and Computer Engineering. Where I'm working on a NASA-sponsored project to bring wireless power to the moon, teaching a class on antennas, and mentoring female students. It feels like I'm living a dream. I'm thankful to ARCS, and in particular, my donor, Washington Research Foundation, for helping to make this possible. WRF's financial support has helped alleviate financial concerns and allowed me to focus on my research. When it comes to my research, one meaningful experience that stands out from my first year is when I joined a project to investigate using electromagnetic energy to harvest water on Mars. In addition to increasing my research skills, I got to work alongside a senior PhD student who was also a Black woman. This positive experience increased my sense of belonging while simultaneously setting me up to take a lead role in my current NASA-sponsored project to bring wireless power to lunar landers and rovers, which could launch as early as 2025. Another current research focus of mine is ambient energy harvesting. It's based on Earth, but still exciting, because we're working toward using the wireless energy that's all around us to power small devices, like Internet of Things sensors. The potential to reduce humanity's power consumption by reusing existing energy is intriguing. Another meaningful aspect of this work is I've had the chance to mentor 4 aspiring female engineers, including high school and undergraduate students. As I start the next phase of my PhD journey, I'm motivated to continue advancing engineering research in space while also advancing the careers of underrepresented people in STEM fields. And I'd welcome the opportunity to join an institution where I can continue this research and mentorship. Looking ahead to those of you here today and the entire ARCS community, I ask you to please give generously and know that you're giving more than just funds. You're giving opportunities for growth and development for the best and brightest in STEM to grow in research skills and research impact. Thank you for your support, and please keep giving big. It's now my pleasure to introduce our next scholar speaker, Katie Sun.
Today, I'm an infectious disease epidemiologist, a computational nerd who, of all things, finds joy in building models of complex disease systems using math and statistics. Now, my transition into research didn't happen overnight. I was first introduced to epidemiology while working at a veterinary hospital, where I saw firsthand how simple tools in outbreak investigation could be used to curb an outbreak of canine parvovirus among unhoused pets. Having witnessed this interplay between socioeconomics and ecology, I became fascinated in how infectious diseases establish themselves and why they spread among certain populations. I returned to school for a master's in public health, and soon after graduating, I moved to Washington, D.C., where I joined a small research organization. Now, this group was known for having an outsized effect on shaping the global health response to antimicrobial resistance. And naturally, I wondered, how did they achieve this? Well, on my first day of work, I met my immediate team: an IT specialist turned disease ecologist, a math modeler, a health economist, a clinical microbiologist, and even an infectious disease clinician. Very quickly, I realized the key to their success: a diversity of perspectives. Meanwhile, I continue to cultivate my passion for One Health by volunteering at the Smithsonian Zoo's Global Health Research Program. Working alongside wildlife veterinarians, I gained valuable insight into the complexities of zoonotic diseases like SARS and avian influenza. These are diseases transmitted between animals and humans. As I learned more about the dynamics of host-pathogen interactions and the important role of human behavior in disease transmission, I saw the potential for computational models to help us better understand these complex systems and inform more effective prevention and control strategies. These experiences were what fueled my interest in zoonotic disease modeling and solidified my desire to pursue farther education in the field. In 2019, I applied for doctoral programs, and in early 2020, COVID happened. In the same wake of receiving competing offers from graduate schools, Governor Inslee issued a state of emergency. Suddenly, on one hand, the research I wanted to embark on became all the more timely and relevant, while on the other hand, concerns for family and friends and questions around financial stability moved to the forefront. This is where ARCS made a difference. When I received my financial package from WSU, the generosity of the ARCS Foundation was the reassurance I needed to commit fully. As we all know, the road to a PhD can be a long and often lonely one, only compounded by remote computational work. And so beyond financial support, the opportunity to become an ARCS scholar was a reminder that there could, and there would be, a larger support network present throughout my journey. One that recognizes not only the importance of scientific research, but also the responsibilities we have collectively to support each other throughout our careers in science, and individually as graduate researchers trying to make a meaningful contribution. Now, 4 years into WSU's Immunology and Infectious Disease program, I found my stride, once again, in an interdisciplinary team. As a part of the Ecoepidemiology of Zoonotic Diseases lab, I build models to try to better understand the risk of disease transmission between animals and humans. Thanks to my ARCS donors, Alicia and Jeff Carnevale, I have a lightning-fast computer, which for me can be the difference between running a model for 1 week versus 1 hour. In my current research, our team combines approaches from machine learning, ecology, and genomics to predict the wildlife reservoirs of emerging viruses. By combining data across biological scales, from broad macroecological data to fine-scale viral genomic data, we're able to gain insight as to why some viruses infect a broad range of host species, while other closely related viruses infect only a few species. Looking forward, I am very excited for the future of computational modeling in One Health and how it can guide us as we shift the infectious disease paradigm from reactive management of risk to preemptive management of risk. As someone who's benefited tremendously from the willingness of others to collaborate across disciplines and backgrounds, I hope to bring my interdisciplinary training to all of my future endeavors, whether that's supporting future ARCS scholars or seeking a position at the CDC's Epidemiological Intelligence Service. I truly believe that helping other early career scientists see a clearer path in interdisciplinary research not only promotes greater diversity in STEM, but also creates more impactful, sustainable solutions to global health issues. And with that, I want to thank you all for being here. As my husband can attest to, it's no small feat to get me away from my laptop, but it meant so much to me to be here in person to thank you all. I do hope you'll give generously to the ARCS Foundation, knowing that your support is going to go a long way in creating opportunities for future ARCS scholars and STEM scientists like ourselves. Thank you so much. Thanks. And now I'd like to introduce Ramon Rojas, our next speaker.
Thank you, Katie. I've been a big nerd my whole life. When I was in elementary school, I loved watching science documentaries about space or the brain. I was just fascinated about the unknown and curious about how the world works. I wanted to know what makes us who we are. And as I got older, I realized that neuroscience was a passion of mine, but I didn't know how to become a scientist. Thankfully, I've had countless friends, mentors, instructors, and family that have supported me, advocated for me, and helped me see potential paths forward. They've been guiding lights in my journey as a scientist, and I've come to realize that I want to be a guiding light. I want to care for, I want to support, and I want to inspire the next generation of students and scientists, because I believe that to inspire is to share hope, and to have hope is everything. My first exposure to research was in high school when my biology teacher, Dr. Gonzalez, brought in these microscopic worms called C. elegans to show us what research looks like. And I was fascinated over these worms. C. elegans are a model organism, meaning that we can use these worms to try to understand their nervous system in hopes of getting some insight or some idea of how our own nervous systems might work. So for example, in us, our neurons, or the cells in our brains that send chemical or electrical signals, they use these molecules called neurotransmitters to communicate with one another. Dopamine is one of these neurotransmitters. Dopamine is necessary for motivation, for learning, and for movement. And loss of dopamine can be extremely detrimental. For example, in Parkinson's disease, the brain loses much of its dopamine because the neurons that produce dopamine die off for some mysterious reason. As a result, folks who develop Parkinson's disease later in life end up developing a tremor and can have mobility issues. Well, what about the worm? Well, the worm also uses dopamine. And can you guess what it's used for? Movement. If we kill the dopamine neurons in the C. elegans worm, the worm also ends up developing movement issues. And so, as you can see, our nervous systems work surprisingly similar to the worm nervous system. And we can try to use this to our advantage to then understand the pathology of several diseases, such as Parkinson's disease. Now, obviously, I didn't know any of this when Dr. Gonzalez brought in the C. elegans worms to school. All I saw were petri dishes and microscopes, and I was like, wow, this is super cool. Like I said, I was and still am a pretty big nerd. But this experience, it inspired me. It inspired me to pursue my passion for science, and now I actually had a tangible idea of what being a scientist could look like. And so I came up with a plan. I was going to major in neuroscience. And so I graduated from Pomona College with a bachelor's in neuroscience, and I subsequently joined the graduate program in neuroscience here at UW with a continued passion for trying to understand how the brain works. And today, I still am working with C. elegans worms, and they still have my heart. I'm currently working in Dr. Akanksha Singhvi's lab, where we're trying to unravel how these other brain cells called glia help and support the brain to remove dying and dead neurons. So interestingly, our brains are made up of, half of our brain is made up of neurons, but the other half is made up of these cells called glia. For the longest time, researchers paid no mind to glia. They were just the glue that held the brain together, and they were so wrong. Glia are so important to the function of our brain. They're necessary for learning and memory, they're necessary for sleep, they're necessary for proper brain development, and that's just to name a few functions. I could go on forever, honestly. But what I loved about glia is that we really didn't know much about them. It was this new unknown that I could walk into. And so my research focused on asking, how do glia cells remove dead neurons? Most research in neurodegenerative disease focuses on asking, why are these neurons dying? Why is our brain degenerating? But no one really asks, how do these dead cells actually get removed? And what happens if we don't remove these cells? I think there's two possibilities. On one hand, these dead cells remain and nothing really happens. Or on the other hand, these dead cells are now releasing a lot of toxins into the surrounding area. And as a result, the healthy tissue is now becoming dead tissue. It's starting to degenerate. And so this causes more widespread degeneration. I believe that in order to have more effective treatments for neurodegenerative diseases like Parkinson's and Alzheimer's dementia, we need to understand how both neurons and glia contribute to these diseases. I hope that my research will highlight the importance of glia in health and disease, and this will in turn lead to more targeted and effective treatments of these diseases, hopefully in our lifetime. Much like my mentors at high school and in college, my mentors here at UW have supported my growth as a scientist and as a future mentor. I hope that I will continue this and pass this along by becoming a community college professor. I want to teach biology, I want to mentor students, and I want to support them as early as possible so that they can also see what being a scientist looks like, and if that's what they want to do. And finally, I certainly would not be here without ARCS. ARCS has been wonderful and has been a great financial support and also has really helped build my confidence. I think ARCS is a wonderful foundation, and I hope that today, with your continued generosity, we can continue to support scientists and inspire the next generation of students and scientists to care for one another, to support one another, and to continue exploring what makes our brains so remarkable. So with that, I'd like to thank you. And next, I'd like to invite Camille Wagstaff to share her story with us.
Thank you, Herman. I am so honored to be here today. As I stand before you in my final year as an ARCS scholar, I'm filled with gratitude for the generous support and resources this foundation has provided. Out of my 4 top choices, the ARCS scholarship is what helped me to decide on my current PhD program. Your financial support has allowed me to embark on a remarkable journey, one in which I have presented my research at numerous conferences. These experiences have allowed me to meet both domestic and international pathologists with whom I still collaborate. One of these conference associates has joined my PhD committee, and together we are applying for United States Department of Agriculture grant for multi-state specialty crops. I was fortunate to receive the 2nd Floyd Rogers Memorial Scholarship, donated by the one and only Judy Rogers. Judy has welcomed me with arms wide open and introduced me to countless inspiring women. I'm so grateful to be supported by such visionary women dedicated to furthering science through the ARCS Foundation Seattle chapter. I earned my Bachelor of Science in Anthropology from Boise State University in Southwest Idaho, where I focused on traditional ecological knowledge and native land management methods. My favorite class was federal law and tribal policy, prepping me for this past year when I had the opportunity to meet with 3 tribes and Governor Ainsley to discuss promoting the use of locally grown hemp to develop building materials such as hempcrete and hemp insulation. These products are already being utilized in today's industry to help with the shortage of building materials. Cape Town, South Africa, just built the world's first hemp skyscraper using hempcrete, which also sequesters carbon. I hope my contributions enhance the health of our planet by uniting scientific research with policymaking. As early as I can remember, I've always loved bugs. My dad was in the military and would bring me back bugs from all over the world, cultivating my interest in biology. The variety of different insects got me curious about the diversities throughout our planet. Now I'm earning my PhD in molecular plant sciences through the Department of Entomology, and I am in my 3rd year at Washington State University. Go Cougs! Specifically, I research viruses and bacteria that cause various plant diseases and are spread when insects feed. By analyzing insect behavior and plant pathology, I hope to make pest management methods more effective by decreasing pesticide use while still increasing crop yields. By pinpointing the thread of timing created when these infected insects move into crops, we can better inform farmers of when their pesticide applications are most effective. My research is being used to develop prediction models for timing insect migrations and plant vulnerability. These models are shared on WSU's Decision Aid system, which is an easy-to-use online platform for growers. Since the adoption of these monitoring systems in Washington in 2007, pesticide use has decreased by 33%, resulting in $9 million annual savings in the potato crop alone. Excuse me. Let's see, by analyzing, I would like to look at how different diseases spread across different landscapes. And so I employ molecular techniques to analyze which plants insects are feeding on, and I do pathogen testing on those plants and insects. In particular, I research the beet leafhopper, which is notorious for spreading a wide range of diseases to many crops. A virus these insects spread, beet curly-top virus, devastated the sugar beet industry in the early 1800s and recently has reemerged in Western states, causing significant economic loss. Over the past 3 years, crop fields reports have quantified 90% disease incidence, ruining numerous vegetable, fruit, seed, and hemp crops. As insect ranges expand, I'm collaborating with scientists in Oregon, Colorado, and New Mexico to share research findings on affected regions, as bugs don't seem to be concerned about state lines. I'm now conducting greenhouse experiments on various plant species to better understand susceptibility to curly-top virus. After I graduate, I'd like to continue my career in molecular biology. I find immense satisfaction in lab work and diagnostics, and I particularly enjoy the tranquility of working in a greenhouse in winter, as many of you might do. I regularly volunteer at outreach and education events to get kids excited about science and open their minds to the possibility of pursuing a career in a scientific discipline. I'm committed to mentoring to further STEM in the same spirit of guidance the ARCS Foundation has provided for me. I hope to encourage more women to pursue their interests in contributing to humanity's welfare through science. You have ignited my passion for fostering scientific curiosity. I am grateful on a daily basis for the opportunities that you have provided for me. It is my fervent hope future scholars will have these same opportunities as a result of your generosity today and into our future. Thank you.
Wow. Thank you, Camille and Katie and Herman and Shanti. I am inspired and enlightened and so appreciative that you shared your journey with us today and told us a little bit about your research. We look forward to hearing more in the future. I'd also like to thank Dr. Jevin West for his talk that was intriguing and very thought-provoking. Next up, we have a video highlighting the impact of ARCS Foundation, followed by a short message from board member Judy Rogers.
Nation means a lot to me because it means that I can attend academic conferences and continue to do research without having to worry about the cost of living quite as much as I would without the donation.
I know I'm in the right place. I feel like I can do anything here.
When the ARCS scholarship was offered, it just became an offer that I couldn't deny. It was the perfect incentive that I needed to finally choose to come to WSU.
Throughout my career, I'm looking forward to demonstrating the value that ARCS has contributed to my experience here at the UW. And I really hope that all of you at this event, through your giving today, are able to help future fellows have a positive impact on the world.
I really couldn't be here without the network of mentors and peers. Seattle's a community of people that care about technology, they care about science. I think that supporting scientists and individuals like that is one of the greatest gifts, and I'm thankful to ARCS for doing exactly that.
I'm Judy Rogers and a board member of ARCS Foundation. In case you haven't noticed, I can be a little unconventional. For starters, put away your checkbooks and your credit cards or whatever method you were going to use to make an investment in these current and future scholars. You were going to make a donation, right? Where else out there can you get this fabulous of an ROI, return on investment? Forget about the amount you plan to invest. We're celebrating 45 years, yes, 45 years of ARCS Foundation Seattle chapter igniting scientific innovation. I promise I won't be up here for 45 years, months, days, or even minutes. You saw and heard the wonderful things that Dr. Jevin West and astronaut Jessica Meir, as past ARCS scholars, have accomplished. But let's focus on the current and the future. We heard about fantastic research by Shanti, Herman, Katie, and my scholar, Camille. I am so proud of Camille for all of her research and the amazing possibilities for the future. Think about what discoveries might be possible over the next 45 years because of your investment. What problems will the scientists in this room today solve? Can you stretch the amount that you were going to give by 10% or 25%? How about 45% in our celebration of 45 years? I'm sure you can all figure out the math part to do that. We have a matching pool today given by the ARCS Foundation Board of Directors. The first 14 online gifts at the $1,000 level will be matched. For some of you, you may be interested in supporting a scholar through a fellowship or even an endowed fellowship. Will an extra $50 or $250 make a difference? The answer is yes. Every gift, big or small, can make a huge impact. Okay, now you can get out your checkbook or your credit card and think about the great innovative research these scholars are doing. Take a moment to fill out the pledge cards on your table. I know they're in an envelope, or use the QR code, because then you can give immediately online. No waiting, we make it be easy for you. So thank you from the bottom of my heart for supporting future students and what they will discover in the next 45 years. Whatever your gift or investment amount today, it is greatly appreciated. Thanks so much. And now I welcome Jenny White back to the stage. Here you go, Jenny.
Well, I think I'm going to chase down Judy so I can borrow that cape for Halloween. I see you filling out your pledge cards. Thank you. I'd like to point out that there are some little boxes at the bottom of the card. So if you're interested in contributing to a fellowship or an endowment or setting up a bequest or even becoming a member of our stellar organization, ARCS Foundation, please check a box, and we'd really love to hear from you and connect with you. Our time has come to a close, and our scholars are going to lead the way out. So as you see these young scientists, we hope you will see them and recognize the value of your support. And I also hope you'll leave today feeling a little more optimistic about our future and our world. Thanks so much.